This is Unit 7, BTEC Engineering, Section A22, the Section A Examples booklet on page 40. As usual, this is a video, not a lesson, so you will need to pause to take notes in order that you are able to successfully complete your assignment. Also, the mathematics involved in assignment is at a very high level, so if you do find it very difficult to follow, just try and see if you can basically follow the process through with a similar equation with different numbers. Best of luck. Right, so as we've been doing for the last few sections, we need to find the first and second derivative. So in this case, we've got u equals sine of 1.9t and v equals t for a quotient rule. So we've got a quotient, a fraction, to differentiate. So we need to sign u for the numerator and v for the denominator. Now for the functions we need to differentiate here, we've got k times t differentiates to k. We've got t to the n will differentiate to n times t to the n minus 1. Multiply by the power, take 1 off the power. Sine kt differentiates to k cos kt. And cos kt differentiates to minus k sine kt. So that's what we need to be able to do. So the first one is sine 1.9t. So du by dt, the k is 1.9, so it's this rule, 1.9 cos 1.9t. The v by dt, it's k times t, the k is 1, so it differentiates to 1. Apply the quotient rule, ds by dt equals v times du by dt minus u times the v by dt, all over t squared. Sub all those in, so v times du by dt is written 1.9t cos 1.9t minus the v by dt times u, so 1 times sine 1.9t, all over v squared, so I should have written v squared. The v is t, so I keep writing t squared there. So it's v squared for the quotient rule, it is t squared in this particular case. Right, so we need to differentiate again to get d2s over to t squared. Now we've got a product and a quotient. So the product is 1.9t cos 1.9t, and we've got a quotient, we've got a fraction. So let's do the product rule bit first. So we've got 1.9t cos 1.9t, so our u is 1.9t, our v is cos 1.9t. Du by dt, kt goes to k, so that becomes 1.9. The v by dt is cos 1.9t, so that rule, minus 1.9 sine 1.9t. Now we apply the product rule, so v times du by dt plus u times the v by dt. So we've got 1.9 cos 1.9t plus 1.9t times minus 1.9 sine 1.9t. So simplify, 1.9 cos 1.9t so 1.9 times minus 1.9 is minus 3.61. We've got a t and we've got a sine 1.9t. So when we're doing the quotient rule again, we've got u equals 1.9t cos 1.9t minus sine 1.9t. We've got v equals t squared. Du by dt, well, we've just differentiated that function 1.9t cos 1.9t here, so we've got 1.9 cos 1.9t minus 3.61 t sine 1.9t. And then we've got minus sine 1.9t, sine kt, the k goes to the front, so the 1.9 goes to the front, cos 1.9t. And what happens with this sort of expression is these two terms will cancel, so we'll just get minus 3.61 t sine 1.9 t. For the v equals t squared, well, we've got t to the n, so the power, the 2 goes to the front. We take 1 off the power, 2 take away 1 is 1. We don't need to write powers of 1, so we just get t squared goes to 2t. Apply the product rule again. So v times du by the t minus u times the v by the t all over v squared. So v times du by the t, well, t squared times t is t cubed, so we'll get minus 3.61 t cubed sine 1.9 t minus u times v by the t. We've got 2t times this whole thing, so we can put that in brackets. So 2t, 1.9t cos 1.9t, that's space, minus sine 1.9t, close bracket, all over v squared. T squared squared is t to the power of 4. This could be simplified, but you don't need to simplify it to get the required pass from it. So S equals, so for reference for later, sine 1.9t over t, ds by the t equals, where are we, 1.9t cos 1.9t minus sine 1.9t over t squared, and d2s over t squared equals minus 3.61 t cubed sine 1.9 t minus 2t, open bracket, 1.9 t cos 1.9 t minus sine 1.9 t, complicated expression, all over t to the 4. And we'll need all of those for later. So first of all, we need to find the gradient, so it's just a case of putting t equals minus 1, t equals 1 into those functions. So, t equals minus 1, gradient is ds by the t. So we put minus 1 into that formula, so 1.9 times minus 1, cos 1.9 times minus 1. I'll need to in brackets for the calculator to realise what you're doing cos of, minus sine of 1.9 times minus 1 all over minus 1 all squared, and calculate. So let's do that. Make sure your calculator's in radians. If it's not in radians, put in radians with shift mode 4. We'll put your calculator into radians. So sticking all that in, to 2 decimal places I get 1.56. And then same again, but t equals 1. Out the same formula, but 1s instead of minus 1s. So 1.9 times 1 cos 1.9 times 1 minus sine 1.9 times 1 all over 1 squared gives minus 1.56. 2 decimal places. As usual, that's what you need to do to get past. To get merit and distinction, you need to explain your method and compare your answers to the graphical method. So these have been obtained from calculus, so they're the correct exact answers. You make a comment on that, and then you would basically rate how good your estimates were and how close they are to these actual answers. So if they're close, good estimates; far away, bad estimates. Doesn't matter if they're good or bad, just as long as you make the correct comparison to get the merit and distinction. Part C. So as usual, to find turning points, you need to solve ds by the t equals 0. So in this case, ds by the t equals 0 is 1.9t cos 1.9t minus sine 1.9t all over t squared equals 0. Well, you can times both sides by the t squared. On the left hand side you just get left with the numerator. Right hand side, 0 times t squared is still 0. So we end up just having to solve that equation, and from the values, we only want to deal with it for the graph that we plotted way back in A10, so that the t we plotted was between -4 and 4. So what we need to do is to, again, this can't be solved algebraically, just like the one in the last section couldn't. So we need to use Wolfram alpha. Let's bring that up. So again, just like the last section, we type solve. We put the equation in, 1.9t. I like to use spaces, it makes it more likely to recognise what I want it to do. 1.9t cos 1.9t minus sine 1.9t equals 0, comma, -4 is less than t is less than 4. And actually I should add that t can't equal 0, because you can't, the formula has t in the denominator and you can't divide by 0. That's why it breaks in the graph that we plotted way back in A10. Now, in this case, if we get an answer of 0, we'll just ignore it. So I haven't typed that t doesn't equal 0 in because it's awkward to do. But as I say, I get an answer of t equals 0 here, I'm just going to ignore that. I'm going to pretend it doesn't exist. Right, so panning down to get our solutions. We've got t equals -2.36495, and we've got t equals 2.36495. Remember, this is a symmetrical graph, so it's not surprising we just get plus or minus the same number. As I've said before, we can't, t equals 0 doesn't work in the original formula, so it's just a solution that we're ignoring. So we've got our two t's. So we go back to finding the s's, so the s, stick it into this formula, sine 1.9 times -2.36495 divided by -2.36495. So calculating, we get -0.4127, so on, so it's two decimal places, -2.36 minus 0.41. Same for the other point, so s equals sine 1.9 times 2.36495 divided by 2.36495. Use the replay button on calculating, just delete the minuses, and we get the same value out, minus 0.412, so on. So the other point is 2.36 minus 0.41 to two decimal places. Now we have to identify if they're maximums or minimums. So we need the second derivative, which is this horrible equation here. So d2s over to t squared equals, and we need to stick that value in. I'm not going to write it all out because it's going to be horrendous to do so. So saying it out loud, minus 3.61 times, open bracket, minus 2.36495, close bracket, to power 3, sine 1.9 times minus 2.36495, close bracket, minus 2 times minus 2.36495, open bracket, 1.9 times minus 2.36495 cos 1.9 times minus 2.36495. Starting to wonder if this will all fit. Close bracket, minus sine 1.9 times minus 2.36495, close brackets. In fact, it won't fit, so I'm just going to do the numerator. Equals probably a bracket missing. There we are, 46, and then I'm going to have to divide by t squared, so minus 2.36495 to the power 4 equals, and I get 1.49, which is a positive value, so the point is a minimum. I'm going to have to do the same thing, alas, for the other point. I believe we could just get the same value out. I'm not 100% sure, so we're going to have to do it. Minus 3.61 times 2.36495 to the power 3 times sine of 1.9 times 2.36495 minus 2 times 2.36495, open bracket, 1.9 times 2.36495 cos 1.9 times 2.36495 close bracket minus sine 1.9 times 2.36495 close bracket, close bracket. So divide by 2.36495 to the power 4 equals, as expected, a lot of effort just to get the same answer. 1.49, which is greater than 0, the point is a minimum. So that's what you need to do to get the pass mark. To get embedded distinctions, you need to explain your method and compare your answers obtained by the graphical method in A10. Oh, and another point, but we should really credit that we've used Wolfram Alpha at that stage. So, and that should, something you should go back to the last section and add in before as we use Wolfram Alpha, we should basically quote that we use it. So it's fine to use it, but we do have to say that we have. Right, to get mental distinctions, you need to explain your method and compare your answers to those obtained in A10. So these are the precise answers. If they're close, good estimates. If they're far away, bad estimates. Basically the same normal comments that we usually make. Best of luck.